Hi, I'm Don DiPietro, Vice President of Product Management and Applications at Canon Instrument Company. Our history starts at Penn State University, where there were two professors, Dr. Fensky and Dr. Cannon, who improved upon a manual glass viscometer. There were systematic errors, which they corrected, and they started the company in 1938. And little did they know the extent to which they would revolutionize the kinematic viscometer industry in petroleum products. Since those times, Canon has grown outside of petroleum into polymers in particular, and we have two instruments that we want to exhibit here at the Pittsburgh conference, which I'll show you now. The miniPV is a viscometer that measures molecular weight of polymers. The importance of molecular weight is well known in the industry. It's probably the most important property when it comes to processability of polymers. I would say it's also vital in the end-use performance. The hallmark of miniPV is its accuracy. The accuracy is derived really from two things. The first thing is the isolation of the polymer molecule in solution. It doesn't have any neighbors to interact with it. So we can get an actual size of the polymer molecule isolated. The other thing that lends itself to accuracy is the way we make the measurement. We simply drop the polymer solution through a capillary and we measure the time of that drop. And we're taking advantage of gravity. Nothing is changing. The dimensions of the capillary do not change. Gravity does not change. It is unlike anything really available for molecular weight. We get much better accuracy even at a fraction of the cost. The final thing about the miniPV is really the automation. When we put these polymers in solution and we look at the very, very low concentrations, sometimes we want to do it at variable concentrations. So in the old days, people used to use manual tube viscometers for this, but it's not necessary anymore. We have complete automation to do those experimental sets automatically. We're also exhibiting our thermal analysis product line. Thermal analysis is really a suite of instrumentation. It includes a variety of techniques called DSC, TGA, DMA, and TMA. It's been known for, since the 1960s. These are well-established techniques. The hallmark of these products is the flexibility of configuration, the way we can have simultaneous cooling devices on the DSC, the way we can interchange furnaces for different applications on the TGA. Also, the robustness. The quality of the design in the robotics and the automation is noteworthy. I would also say the baseline quality, the baseline stability. So with any analytical technique, we don't want the instrumentation itself to add to the measurement. And so this is a very key benefit of the thermal analysis equipment that we're demonstrating here. Finally, it's the ability to view the sample as it's being analyzed. So for things like oxidative stability, degradation, things like as a polymer would cool from the melt, we might want to look at things like polymer structure or the crystal size. And these are unique features of our thermal analysis equipment.